All right, section 8.2. So 8.2 says that we want to find the length. So 8.2 is we have these special right triangles, and these special right triangles have some shortcuts. So if we don't know all the pieces of all the sides, we can maybe find them by using these shortcuts. So here we have a right triangle, and we have two sides that are congruent. They're both x here. So I could just use the Pythagorean theorem here. So the hypotenuse would just end up being equal to x times the square root of 2, okay? So this angle, if it's isosceles and this one's 90, I have 90 degrees left over for each of these ones, so these have to both be 45. So then if you have this theorem, it says in a 45, 45, 90 triangle, so those are all about the angles, both legs are congruent, and the length of the hypotenuse is the square root of 2 times the length of a leg. So I got my leg, so it's the leg times the square root of 2. So what is the length of the hypotenuse of a 45, 45, 90 triangle with a leg length of 5 square roots of 3? So you could use the Pythagorean theorem here again still, but the idea with this shortcut, if I'm taking a leg and going to the hypotenuse, then I just have to multiply it by the square root of 2. So 5, and then the square root of 3 times the square root of 2 ends up being the square root of 6. So my answer for the hypotenuse is 5 square root of 6. If I was going backwards, so if I knew the hypotenuse was 10, and I wanted to go this way, I would divide it by the square root of 2 because I'm going in the opposite direction. So I would take 10 divided by the square root of 2 to find a leg. Again, you could use Pythagorean theorem. Remember, we don't like those square roots of 2 in the denominator, so square root of 2 over the square root of 2. So I get 10 square root of 2. Square root of 2 times the square root of 2 is 2. So I have 5 square roots of 2. If you look here, so remember in the beginning we started off with 10 over the square root of 2. Like I said, we don't like those square roots in the denominator, so 10 divided by the square root of 2. So I get this. But then if I looked at 5 square roots of 2, it would be the same thing. Okay, so that's why it's working out to the same math there. All right, but this is the preferred answer from a mathematician perspective because we don't like those square roots in the denominator. All right, then there's another one. This other one is called a 30, 60, 90 triangle. So in the 30, 60, 90 triangle, the length of the hypotenuse is twice the length of the short leg. The length of the long leg is the square root of 3 times the length of the shorter leg. So in this one, so I've got this angle, there's my right, there's my 30, there's my 60. So if I start off with the short leg just being x, the hypotenuse is 2 times x. The long leg is x times the square root of 3. So if you look here in this one, I've got the 5, which is opposite the 60. So I have the long leg. So if I want to go backwards to the short leg, so if I had the long leg and I'm going backwards to the short leg, I have to get rid of that square root of 3. So I'm going to divide it. So d is going to be 5 divided by the square root of 3. Remember, we don't like those square root of 3's there, so we rationalize it. And we get 5 square roots of 3 over 3. Can't do anything else with that answer. I can't cancel anything out. Well, now that I know the short leg, to go from the short leg over to the hypotenuse, it's just easy enough to multiply by 2. So to get f, I'm going to take the short leg, and I would have 10 square roots of 3 over 3. All right, to go from the long leg to the hypotenuse, that's kind of hard to do because this is the x square roots of 3, and this is the 2x side. Like, it's kind of hard to do that, so I think it's always just easier to take that, go back to the short leg, and then take the short leg and go to the hypotenuse. Okay? All right, let's do a couple of these homework problems together. So let's see here. Let's do, I'll do, some of them are pretty straightforward, so I'll just do the last two with you, okay? So, because those ones are probably going to be your hardest ones. So let me find chapter 8 in here. All right, so 30, okay. So 30 has this interesting picture here. It says we've got some heavy winds that have damaged a house, so the workers place a 6-meter brace against its side at a 45-degree angle. Then at the same spot on the ground, they place a second, longer brace to make a 30-degree angle with the side of the house. How much longer is the how long is the longer brace? So how long is this brace? Round it to the nearest tenth of a meter. And then it says about how much higher does the longer brace reach than the shorter brace. Sorry. So what I'm going to do here is I'm going to look at these as two separate triangles. So we know we have one that goes like, we have a 45, 45, 90. So, and in that one, the hypotenuse is 6. Then we have this 30, 60, 90. This is 30 up here. There's the 90, 60 down here. And we do want to figure out the length of this brace right here, okay? Well, over here, this side right here and this side right here are actually the same. It's the same part of the triangle. And if this is a 45, 45, 90, and it says here I could round it to the nearest tenth. So to get over here, I can just do 6 divided by the square root of 2. So 6 divided by the square root of 2 is like, I'm going to keep a couple decimal places here just because I'm still going to use this number later on, so I don't want to mess up an answer later. So I kept 4 decimal places. So that's what this side is. That's also this side right here. So then I know that part of this side right here is equal to that. Now I know that this side right here is this. Okay, well now I have the short leg. So to get the hypotenuse, so for part A, to figure out how long is the longer brace, I can just take the short leg and multiply it times 2. So I can just take that number and multiply times 2. So I get approximately 8.5 for the longer brace. So again, I'm taking that 4.2426 times 2 because it's from a 30/60. Okay, but again, if I know the short leg, I can also figure out what this side is here. So to figure out that side right there, I would take the short leg times the square root of 3. So I'm going to take this number from up here times the square root of 3. Oops, 3. So that's what, so the height, so B, I know that this height right here, how high it is off the ground, is 7.3485. But B asked me how much higher does the brace reach than the shorter brace. So then I would subtract it. Over here I had a 45, 45, 90. This side was 4.2426. So this side is 4.426. 4.2426. So then I subtract. I kept a lot of decimal places there. So then I get approximately 3.1 meters, okay? All right, for 33. All right, what's going on here with 33 is you have this little cube here. But if you notice here, this is the bottom of the cube, and there's a line here, then there's a diagonal here, and then there's a height here. So there's a right triangle right here. This height right here is 1. You want to find the length of the diagonal. The problem is I need to know this height, this length down here. But I know that the bottom of it, so it's 1 by 1 at the bottom, and that dotted line, so it's forming a right angle right there too. So this bottom part is a right angle, or a right triangle. So if I just did 1 squared plus 1 squared, I don't know, let's call it x squared, I'd have 2 is equal to x squared, so x is the square root of 2. So this bottom now is the square root of 2. But then if you want to find the diagonal, so the bottom I just found out was the square root of 2. This height right here and this side is 1. Here's the diagonal. So the diagonal, if I have 1 squared plus the square root of 2 equals 2 squared to 2 squared equals d squared. This ends up being 3 squared is equal to d squared. So then I get the square root of 3 is equal to d. Okay, so that's, and then you could do the same thing for the other one. So you'd have 2, 2. So 2 squared plus 2 squared equals whatever that line is on the bottom. So we end up with 8. 8 is 2 square roots of 2, so that's that piece there. So again, when I think about the other triangle, I've got the 2 square roots of 2 squared times the 2 squared, which is that height there, and then the diagonal that I don't know, squared. This ends up being 2 squared is 4, square root of 2 squared is 2, so this is 8 again, duh. Then 2 squared is 4, so I get 12. 12 is the same thing as 4 times 3, so 12 I get 2 square roots of 3 for the diagonal in this one. And then lastly, of course, they're saying, what about if it was s units? So you would treat it the same way. S squared plus s squared equals the x squared. So again, pretend instead of 2 and 2 here, I've got s and s. So this ends up being 2s squared. So then I have s times the square root of 2 is equal to x. So there's that right there. This height is s. So I have s square root of 2 squared plus s squared equals the diagonal squared. So this is s squared times 2 plus s squared, so diagonal squared. So then I have 3s squared. And then I take the square root, and I get s square root of 3 is equal to that diagonal. Okay? So that is that one.